So here's a difference between an electrolytic solution and a non-electrolytic solution. Shown here are sodium chloride dissolved in water. Sodium chloride is an ionic compound, and as we mentioned, the main point of this chapter is that ionic compounds will dissolve into their component ions in water. So sodium chloride in water is nothing more than sodium ion and chloride ion, Na plus and Cl minus, aqueous state. Shown here is glucose in water. Now the solute is glucose, the solvent is water, so again it's an aqueous solution. We need to remember that a solution is a solute plus a solvent. So let's add a little bit of this solute here, sodium chloride, which is nothing more than salt, into water. Okay, you notice that, let me just add a little bit here. You notice that the salt will go in the water and will dissolve, so we have essentially a aqueous solution, nothing comes out. And what's the difference between an electrolytic solution and a non-electrolytic solution is that the sodium ion and the chloride ion, as a result of the dissolution in water, the ions conduct. So what I have here is a battery that powers this Christmas light, and connected and wired to this Christmas light are two electrodes. So ions can come in. We know that ions can conduct electricity. The ions can come in, travel along these aluminum conductive wires and light the light bulb. Only if it's an electrolytic solution, only if the solution is conductive. So if I'm going to put these two electrodes and sort of immerse them in this aqueous solution of sodium chloride, you'll actually see that the ions, sodium ion and chloride ion, it's really the electrons that are coming in, traveling up the wire, and providing the power to light up this light bulb. So that is essentially what an electrolytic solution is. This is also known as a conducting solution. Any ionic compound that's completely dissolved in water is a conductive solution or an electrolytic solution. Again, think of your Gatorades and all your sports drinks. All right, let's contrast that with a covalent molecule such as glucose, sugar water. So glucose is carbon, hydrogen, and oxygen. It's completely a covalent molecule. We do not concern ourselves with the structure of it, other than it's covalent. There is no charges. So when glucose is dissolved in water, you notice here that the glucose also is completely immersed and soluble in the water. I put some glucose in here, so I'll put a little bit more. So I already had some glucose added beforehand. But just like in the sodium chloride case, it completely gets dissolved in the water. So you really have a hard time discriminating between these two solutions, salt water and sugar water, other than by taste. One is going to be sweet and one is going to be salty. Another way you can discriminate these two solutions is by noticing that sodium chloride in water is electrolytic and conductive. Glucose, there are no ions here, so it should not light up, and that is what happens when we immerse the electrode in. So there are no ions, there's no conductive capacity here, and this will not dissolute into ions because it's not ionic. So glucose in water is just glucose aqueous state. Sodium chloride in water is a little bit more complicated because sodium chloride in water is sodium ion and chloride ion, and that provides, the ions provide the conduction that allows us to light this light bulb up.